Hey everybody, in this video we're going to cover moderation analyses, which are regression type analysis in JASP and Excel. So what is moderation first to start? Well, in regression analyses, normally we just talk about the predictors predicting some criterion variable. So we've actually done this example as our example for multiple regression, where we use the number of books a person read and their attendance in class to predict their final course grade. And we found that both predictors were important. What moderation allows you to do is look at the interaction between two variables. So just like in ANOVA, where we had two independent variables and we added that interaction, and we spent a lot of time talking about interaction effects, and we should examine those interaction effects, because otherwise why do you have these multiple variables? We can do the same thing in regression. So this allows us to look at the interaction of continuous variables. So before we were doing all categorical variables in ANOVA, where we could break them down into these little groups. So we talked about splitting a variable and then running t-tests. Now what we're going to do is use those variables as continuous variables. So this is really where continuous interactions come into play. Now with regression, you don't have to do the interaction. Which we've seen when we did multiple regression, but you can. So this is the how to do interactions. So you'll hear people talk about moderators. Anytime I say moderate, they're talking about interactions. I don't know why we don't just call them interactions in regression and be done with it, because it often is confused with mediation, which is another video that you should watch. But mediation is the third wheel analysis. So how a third variable influences the relationship between two variables. So you can think about it as mediation, like the lawyer term, or I always think the third wheel. Moderation is all about interactions. So you got to kind of keep those two separate because they're very different approaches and different hypotheses. So we're going to look at the interaction between books and attendance to predict final course grade. And mainly this is pretty much regression. So all the data screening will be very similar with like a special caveat. So we're just going to focus on how is this different than regular regression. So I'm not going to go over all of the ins and outs of regression again, but mainly focusing on how moderation is special type of regression. And one of the big things we have to do is deal with additivity. So when you have two predictors in an equation, we are normally concerned that they're not so correlated that we're wasting our time. So that's the assumption of additivity. Because a bad thing would be multicollinearity, two correlated variables. Now when you add an interaction, all you do is multiply those two variables together. So we're going to take books and multiply it by attendance to get the interaction. Or rather, we're going to make JASP do that, but that's what it's doing. Well, when you do that, that is a perfect transform, meaning 1 times 2 equals 3, and then we're using all three of them in our equation. So we have to be very careful to not create a perfect solution, meaning mathematically they're r squared equals 1, or that their variables are too correlated. So when you add that interaction, the variables become too correlated because that interaction is the other two variables. This is similar to adding a total score and the subscores, because the subscores add up to the total score. Okay. So the one way that people have come up with to solve this problem is called centering. Okay. There are two options in centering. I've seen both ways. We'll do, I feel like mean centering is a little more common, but z-scoring is also pretty common. So we'll do z-scores because we know how to do those. But what centering is it takes that variable and it centers it over 0. So remember what z-scores do is they transform a variable into the normal standard distribution where the mean is 0 and the standard deviation is 1. And that's very convenient to have the mean of every variable be 0 because what that does is it means that 0 score is a person is average. So this is the kind of back to the interpretation of z-scores. If I have a z-score of 0, I am on the average for that variable. If I have a positive z-score, my score is above the average. If I have a negative z-score, my score is below the average. So not only does this solve our multicollinearity problem and allow us to meet the assumption of additivity, it also creates interpretations that are a little easier. So it creates this mean of zero. The mean of zero is probably the most crucial point here, where when we're doing this mathematically, if the mean is zero, you multiply x times zero, and the whole thing drops out of the equation. But to not even get into those like really technical details, having the average score be zero is just really convenient when you're trying to interpret things. Z-scoring makes it even easier because then that makes the standard deviations of your variables 1. But either way, if you mean center or you z-score, what we're interested in, therefore, is then looking at those variables in their centered form so that we don't create additivity. Okay. So through here, when your variables are not centered, the b values or the beta values may be negative, but the slopes, when you look at a picture, will look positive. And so your picture will not really match the values that you are getting in your regression equation, and that gets very confusing. And so when the variables are centered, the b and beta values match the picture. So that's another reason to do this. It's just interpretation between the numbers that you're getting and the pictures that you're creating. Excuse me. So how do we create this interaction? Well, that interaction is created by multiplying those scores together, just like books times attendance. And those interaction scores are created after those variables are centered, so the interaction is centered as well. So we're going to center those first and then create the interaction. Now we can do this either mean centering or z-scores. I think mean centering is probably just a touch more common, mostly because a lot of programs like R will do mean centering for you, but z-score options are just as good. Okay, so let's think about power for a second. Oops, helps if I type G, power. Now with power, it's the same as our regression analyses that we did in our multiple linear, hierarchical linear videos, except that we have to remember that there's this extra variable in the equation. So it's we're going to do this as like an addition of a variable because we want to know if the interaction is important. You can also do this as an overall test. Either way, kind of works the same. So we're going to click on t-test, and then linear multiple regression, fixed model, single regression coefficient. Because we're only really interested if that one variable is important. So I'm interested if that interaction is significant. Okay. There's a couple ways to do this. This is just one of them. Okay. We're going to do two-tailed test. We're going to estimate partial r squared for that interaction. So you have to kind of think about how big you expect the interaction to be. This follows along with the way we did ANOVAs, where we're testing only the interaction. So I'm going to make this a two-tailed test. And I'm going to determine an effect size. So let's see, what did I do in my example here? A large effect. Click direct, 0.225. Calculate and transfer to main. Alpha is still 0.05, power is still 0.8. The number of predictors here, very tempting to put 2, because I have books and I have attendance. But you have books, you have attendance, and you have the interaction. So it's actually 3. When we're seeing if that one predictor is significant, how many people we'd need, given that there are 3 predictors in the equation. So I got that I would need 26 people to find that interaction, if that interaction effect is large. And so that's what it says here. The number of predictors in a moderation analysis with no other variables is always 3. 1 for X, 1 for the moderator, and 1 for the interaction. You can also include covariates here, where you don't have them as part of the interaction, kind of like ANCOVA, but then your predictors here would go up. So that's power. Now let's try, do some data screening first and create the appropriate data set to run here, and then we'll get into how does this test work. I'm gonna use my data 1 here. And so we've seen this data set before. Let's make it a little bigger. I'm gonna save my file as a regular Excel for data screening purposes. Oops, sorry. So this is our master file. And then let's just test. We've done this one before, but let's just walk through it again on how to check for the assumptions of regression. So first thing we're going to check for is accuracy. So no typos, basically. And books and attendance and grade can't be negative. And grade can't really go over 100. So let's click Data, Data Analysis, Descriptives. Highlight all 3 of these. My labels are in the first row, and I want the summary statistics. And for some reason, it opened my simple slope graph. We'll come back to that document here in a minute, but let's just close it right now. What are you doing, Excel? It's always something with Excel. Alright. This is why you hit save every couple of minutes. Okay, let's try that again. So, we've got this open. This is our master file. We're going to make a no typos file, see if there are any problems with our data set, or it's a tab. To do that, I'm going to click Data, Data Analysis, Descriptives, highlight all 3 columns, labels in the first row, and summary statistics. Hit save. I don't know what the trues were for, but these are our accuracy pieces. So let's look at the min and the max here. So 0 to 4 for books, that looks good. Attendance 6 to 20, that's also good because it's not negative. Grade is 37 to 97, so also looks good. I would say that these are all pretty good. Okay. Hang on to the means here, and the standard deviations. Oops. I'm trying to hit bold. We're going to use those in a minute. Now remember, Excel will create Z-scores for you. We can do that Z-score formula or mean center formula, but the interpretation of these variables will need these means and standard deviations, which we can either get here in the data screening file or through JASP. But just a reminder, it's kind of these are the numbers we're starting on. Now we haven't deleted anybody if we have outliers, so this may change a little bit. So we didn't have any typos. Let's look now at missing data. And I'll just create a new tab here. See if we had any missing data. So there's basically no typos, so I didn't change anything. Now this is a small data set. I can easily scroll through and see that I'm not missing anything. Or we can use our %complete function we've been working with all year. We would do equals count A. I'm going to highlight all 3 columns. This way I'm going to divide by 3 times 100. Click on here, go from the white plus to the black plus, and drag and drop. Okay. So I have 100% of the data for my participants, which means I have 100% for the columns, but don't forget you can do that by doing equals count A. Highlight everybody. There's 40 people in this data set, so I'm going to divide by 40 times 100. Drag across here, so I know that I have 100% of my data all the way across. All right, so our missing data looks good. Let's look for outliers. The interesting thing is the way we check for outliers actually is the way that you create centered variables if you're going to use z-scoring. So You're actually kind of creating your centered scores before you start, but we don't want to center the DV. So that's something we need to make sure we get written down in our Word document here about centering, is it's just for the IVs. So let's put that in caps. Do not center the DV. The problem is with additivity with our IVs, so we don't center the DV. But we're actually going to check all three of them for outliers. Okay, so remember, you open parentheses, click on the first one, minus, type the word average, open parentheses, click, close, close, divided by STDEV, open parentheses, click on the whole column, close one more time. And we're going to drag these over here, and then I'm going to double click so it'll fill everything in going down. So the nice thing about having these scores is that I can easily tell who's above and below the mean and who's right on the mean. And so that is what's going to be useful for us as part of this analysis when we are looking at our B values. Now, do I have anybody who is an outlier? So I'm going to do conditional formatting, and I'm going to highlight greater than 2.99, conditional formatting, highlight less than negative 2.99. We're just going to kind of scroll through here and see if we have any outliers. And we don't. So what we're going to do is create a final data set. We're going to check for correlations, additivity, before we start, and then we're actually going to create some variables and move over and do the rest of this in JASP. So I'm still concerned about additivity before I even do any centering. So I know the interaction is going to create some additivity, and that is something we have to deal with, but we still need to make sure our IVs are not too perfectly correlated already, because then the whole thing is just going to go to hell. So we want to check the correlation between books and attendance. The point is to be correlated between books and grade and attendance and grade, so I'm going to ignore my DV for this analysis because the IVs and the DV should be correlated. So we'll click Data, Data Analysis, Correlation. Just these first two rows, columns. Okay, I do have labels in that first column. And we see that the correlation between these two is 0.4. And 0.4 is fine. So we'll go back to my final data set here, and I'm gonna do some stuff to it. So we're gonna leave the DV alone, but we're gonna make, and we'll do this as Z. Okay. You can also do this as mean centering. It should give us the same results. Now, the difference here is the B values will be different, but the overall interpretation should be the same. Okay. So we're going to Z-score books. That's the exact same formula we do when we check for outliers. So we do equals, open parentheses, click on the variable here, minus the average, click on the column, double close, close, divided by STDEV, open parentheses, click on the column, close. If you want to do just mean centering, you don't do the divided by. Going to do that for both columns, not for grade. So what we've done is we've created our centered variables, and we're going to use those in our analysis. We're going to do one more thing here that won't make a whole lot of sense until we get to actually running the analysis, but it helps if you go ahead and do it at the beginning so you don't have to kind of reopen a new JASP file. This part here is part of the analysis of the interaction. So we're going to kind of assume here that the interaction is significant, but it does make it easier if you do this first. And we have to pick a variable to be our moderator. And so I can switch whichever variable I want to be my moderator, but you've got to still pick one. So we're actually kind of skipping here to what's called simple slopes. Okay. Simple slopes are the post hoc test for an interaction. When we did post hoc tests for interaction in ANOVA, we talked about doing independency or dependency and then some sort of correction for that interaction. And we were looking at simple pairwise comparisons. Sometimes that's called simple effects. So what we're going to do now is look at simple slopes. Because we're doing regression, and the post hocs are about slopes, right, and not about mean differences. Now, when we do this, we're not going to create low, average, and high groups. So we're not separating people into groups. When we do this, output-wise, it's going to look like that, but we're not literally taking the data set and breaking it into thirds. We're not doing that. Okay. What happens is we're kind of faking the regression to pretend that people are in these low, average, and high groups. So what's actually happening is we're creating these fake slopes as if I were in a low group, in a high group, or in the average group. And so we are mean centering or z-scoring these scores. So whatever regression we run first is the average group. So the first regression we test is like, if everybody is average, what happens? By centering our data, we're saying that the regressions for the first model are average number of books and average attendance. Whew, that was a difficult sentence. I'm sorry. Essentially, this here says when we center variables, the first regression we run, everybody's in an average score. Okay, in a story. The next thing we'll do is create scores as if I were low and as if I were high to calculate the slopes for those types of people. So I can switch X and M. So I can decide that I don't like books, I want to do attendance. That's fine. I always say go with your hypothesis first, and then if one set of slopes just makes more sense to explain to people, do that. What we're going to do is we're going to look at the simple slopes for books. So we're going to pick one variable to split up. Right? And we're going to analyze the other variables. Okay. So what we're going to do is we're going to take, we're going to look at books. That means we have to split by attendance. So you pick one to split and then one to look at. Okay. If you split one, don't look at it again, because when you split it, it's always going to have the same numbers. I know that doesn't make a whole lot of sense, but you'll see that in a minute. So effectively, what we're trying to figure out is if I am at an average level of attendance, this is the main model, what's the relationships between books and grades? If I'm at a low level of attendance, what's the relationships between books and grades? And if I'm at high levels of attendance, what's the relationship between books and grades? This is just like a post hoc test for ANOVA where we split on one of the variables. But instead of assigning people to groups, we're just going to kind of pretend that we're at average scores or at low scores or at high scores. Now the way we do that is we have to create these slopes ourselves. So I'm going to come back over here and I have to create my attendance slopes so that I can look at books. So we're going to do Z attend low and Z attend high. And this is where using Z-scores really is helpful, because I don't even have to think about the mean and standard deviation at the moment. The way you create low scores and the way you create high scores is by either adding or subtracting 1. When you Z-score a variable, the standard deviation becomes 1. So the way that you move people up a standard deviation or move them down a standard deviation is to either add or subtract 1. So that's the nice thing about using Z-scores in moderation analyses. Here's the part where everybody just goes, the fuck you talking about? Okay. So to create a low group, we have to add a standard deviation. And that makes zero sense to people usually. Because if you think about it, a low group is a group that is 1 standard deviation below the mean. And there's like violent hand gesturing going on right now, so just imagine it. Okay. What happens is that we have to take everybody and move them up or down to the middle. And so essentially what we want to do here is create scores as if a person who was low suddenly became average, because the average is 0. And that is a useful number in our case. And so what we're doing is we're taking the data and we're shifting it up or shifting it down to move it to the middle. So if I'm a low attendance person, I need my scores to come up for me to be in the middle. So we're going to take that distribution and just like shift the whole thing up so that people who are normally low on attendance are now average on attendance. And then we can look at their scores in our regression. This tends to be confusing to people because you think low group must be minus a standard deviation. Well, they are. They're already a standard deviation below the mean, but to analyze them, we're going to move them up to the mean so we can put a spotlight on them. So what we're doing is we're shifting the data so that they go to the middle so that we can see them. Now, that's a lot of yap. How do I actually do this? Just hit equals, and if you're using Zscores, you just do the score that person had plus 1. And so that moves everybody up to a standard deviation above where they were. So this pretends like everybody's scores were suddenly average. Now for the high attendance group, we have to bring them down. They've been to every class, but let's pretend what would happen to them if they didn't go to every class. So we'll move them down to an average number of classes. So we'll hit equals. Click on attendance again, still we're using the Z-score 1, minus 1. Now let's find somebody who's very close to the mean here. So the average score for attendance, if I highlight it, I can look down here on a Mac, 14.1, or I can go back over here to my accuracy one. So the average score for attendance is 14.1. And so here's a person right here at 14. So they're right on the average. What we're doing is we're seeing how much does it matter, books. How much does books matter when my attendance score is average? That's this column. So then how much would books matter if I had actually been going to class? And so you move me up a standard deviation, or for the low group, I'm right on attendance. So how much does it matter if I wasn't going to class? This is the high group. So how much would it matter if I was going to class all the time? But what we have to do is move them up and down to bring them back to the average. If you don't totally get that, that's okay, because it's one of those things I felt like didn't click for me until I'd done a couple of these. Because I distinctly remember my regression teacher teaching me this and being like, the hell is she talking about? But do remember that if you're creating the variable for a low attendance score, you add a standard deviation because you're bringing them up to the mean. For a high attendance score, we're bringing them down to the mean, so we subtract a standard deviation. What that's going to do is it's not going to change the slope for attendance because it's just a linear transform, so it doesn't really move the slope any for attendance. It just kind of moves the distribution back and forth. But it will change the slope for books. So that's going to change how books influences grade depending on where they are on the attendance scale. So we're kind of like sliding the attendance scale around to see what happens to books. So we split on attendance. We're really interested in books. Now I'm going to take all this data, create myself a new Excel file, and save that as a CSV. Come down here, save as a CSV, because that's what JASP likes to read. And I'm actually going to close this bad boy. Now, I find the assumptions section here to be a little easier in JASP. You can do them in Excel as well. If you want to do them in Excel, do them before you get to the centered stuff so that you don't screen variables you shouldn't. But at this point, I think they're much easier in JASP because it's a couple button clicks. But if you're more comfortable with doing it in Excel, do this on the unscaled variables. It won't really change your analysis, but it's just easier. And then create all of those scores like we just did. That being said, I'm going to show you how to get the assumptions out of JASP. So I'm going to open my file here. You guys can see my folders and folders and folders. Data 1 final here. Okay, so what we're going to do is build our regression model with the interaction. So I'm going to click regression, linear regression. So we're actually going to run the analysis so we can get the data screening, but also then if the data screening is okay, we can look at the analysis. Dependent variable here is grade that they made in the course. Our two covariates are books and attendance. Ignore the other two attendance things right now. Don't put all of them in there, it won't run, because those are perfectly correlated. Attendance, these three variables are the same variable, so it will freak out. Come down here, click on assumption checks, but we're going to do something else first. Okay. So we'll kind of open all of these. Oh, not options, I don't need that. Okay. What we're going to do is we're going to click on model here, and we haven't used this before, and click on ZBooks and ZAttendance together, and click move it to the right. That creates the interaction for me. So now you'll notice over here under coefficients, I actually have my interaction score as well. Okay. So I have created the interaction now, and it's centered because I used my Z-score variables. So don't create those scores and then not use them. Okay. However, at the moment, I'm still interested in data screening. So I'm going to come down here to assumptions checks. And let's look at normality first. So that's our residuals histogram. I'm going to tell it to standardize them. And it's actually pretty ugly because there's nothing here at 0. Okay. So there's this kind of like breakdown effect. I can take out the interaction just to make sure it's not that problem. And so there's something about that interaction that causes it to be non-normal. Okay. So you can kind of see that by adding it and removing it. So with that interaction, we've got some non-normality going on, probably because it's two normal distributions for each kind of group of people. Let's look at the QQ plot for linearity. Linearity is pretty important for regression. So that looks nice and linear because most of them are fairly close. This is the same thing as that PP plot you get in Excel. Let's see here. Residual versus predicted to look at our histogram for homoscedasticity and homogeneity. Our standardized residuals over here, so it's from 2 to 3, it's pretty good. Predicted values, here's the middle, it's evenly centered around the middle, and nice big square box thing. So I would say homogeneity and homoscedasticity are met. Right. And you would want to include all those pictures in your assignments. Right now, though, I'm going to turn them off, just so I don't get them 87 times. But that's the thing I would want to look at. To get the rest of this model that I'm interested in, I want to add R-squared change, just to make it easier for me to read what the numbers should be for reporting, and part and partials. So let's come over here and copy this, bring it back to, is the overall test significant? So I'm going to stick my output right here for the main model. So is our overall test significant? Well, we can come up here and look at these values to determine that, just like we would for regular regression. So I would say, yeah, it's significant. So I got 3 and 36 equals, the equal sign is there, 8.07. P-value is less than 0.001, and our R-squared value is 0.40. So it's a big effect size. Okay. Now, the question becomes, though, is the interaction significant? Or really, are any of my coefficients significant? So that's this coefficients box here, and our part and partials. So our slope for books is significant. So we want to say B is 5.95. Our T value, remember degrees of freedom matches here, so it's 36. Equals 2.48. P-value is 0.02. Our PR squared values is here under partial, and I want to square those. So I got 0.38 times 0.38. 0.38 times 0.38. Ooh, I got 14. Something wrong. Something's wrong there. 0.14. So 14% of the variance is due to books. Let's look at attendance. So these are our main effects right now. And I'm just going to copy this so I don't have to reinvent the APA wheel here. And what that implies is for every 6 books, I get a 1 unit increase in grades, but that is 6 books is Z-scored, so that's kind of hard to interpret. But I would just talk about it being a positive relationship. So as I read more books, my grade goes up because the IVs here are Z-scored, but the DV is not. So interpreting the coefficients is more about just thinking about the relationship between the two. So their scores are going up. Okay, so 5.70. It's also significant, 2.37. P is 0.02. And then this time we have 0.37 squared. Is 0.14. Now the important one, the one I really care about, what about that interaction? So that coefficient is 4.50. T value is 2.10. P value is 0.04. And it's 0.33 squared, which is 0.11. So all of these are nice medium effect sizes. Overall, the model is a large effect, but it's like 3 medium effect size coefficients. Excuse me. Now, let's look at our simple slopes. So I'm going to copy this B for books. I'll come down here. We talked about all this. And that's the average level of attendance. Right? Thank you for fixing that for me, Word. There we go. So at an average level of attendance, books has a positive relationship with grades. Okay. And that overall model is the first one here, is always at the averages. Okay. And so thinking about this, and this is not the best example because these are centered, so they're not quite interpreted that way. But when students are going to class on average, each book is adding 5.95 standardized points to their grade. Okay. So for every book that I read, I get 6 standardized points because the book's variable is Z-scored. I think I said that backwards a minute ago where I said this is 6 for every 6 books. It's for every 1 book. Remember, predictors are for every 1 X, so many B values and Y. Right, so for every 1 book, 1 standardized book, we get 5.95 points on our grade for each standardized book. Okay. We get 6 points on our grade. Okay. So what happens at high and at low levels? Well, we have to run that. So let us get these. Formatting in Word sometimes, it's enough to make you crazy. Let's get the high attendance group. So how do we do that? We go back to JASP, come up here, we take attendance and we swap them out. So let's add the high group. You can do high first or low first. But when you do that swap, you're going to have to change and add that interaction back in. And so this is what we need over here. I'll copy that. How can you check that you're doing this right? When you look at this, this should not change. So all of this should stay the same because we haven't really done anything to the model except shift one of the variables up or down. So the overall prediction stays the same because it's just what's called a linear transform. So we haven't really done anything to how the R squared values. These two should actually stay the same because we haven't really changed them. So attendance was 5.7, interaction was 4.5. We got 5.7 and 4.5. Yeah, we've moved the attendance score for high people, we took them down a notch, right, and made them 0. But that doesn't change the relationship between X and Y. It just sort of moves everybody down one. The slope is still the same. Okay. So the steepness of the slope isn't changing. However, that does change the relationship for books. So this is the one we're really interested in. So let's make it, I don't know, blue. Okay. And so all of these numbers will change. So let's get this one written out. So for a high attendance, B, stop that, equals 10.45. So for every one standardized book, we get 10.5 points on our grade, which is kind of a lot. So T, still 36, is 3.20. Oops. Equals 0.03. And this really shouldn't change a whole lot, but 0.47 squared now is 0.22. So it might be, what you might find is that only one of these is significant. Or maybe two of them are significant. So the slopes should be different. And sometimes they may be significant and sometimes they may not be. So let's come up here and stick this one. This was high. And then it pasted in its own font for fun. So for every one standardized book, we get 6 points on our grade. For the average levels of attendance, if I'm going to class a lot, for every one standardized book, I get 10.5 points on my grade, which is a whole lot. So at average levels of attendance, books are helping us out. At high levels of attendance, books are making even more of an impact. So let's add that here. Each standardized book is adding 10.45 points to their grade. Okay, oops. All right, so when students aren't really going to class, what happens? So let's come up here and now do low attendance. So doing one of these analyses is kind of akin to running just 3 little mini regressions. So let's do low. I switched them out. Now I need to create that interaction again. We're going to copy all that. Come over here just to make sure we've done this right. This F didn't change. Great. These two shouldn't change. Fantastic. This one should change. It's actually not significant. So at a low level of attendance, you might as well just quit because books aren't helping you either. Okay, so 1.45. Our T is still 36. Get my fingers on the right keys here. So 0.46. P equals 0.65. PR squared. And I'm going to take 0.08 and square that. Equals 0.01 if I round up. So here. Let's stick that up here. So we have all 3 of them together. Paste this. Paste in list. There we go. All right, so at low levels of attendance, books are actually not significant. So when I'm not going to class, the books aren't helping me. when I go to class an average amount of times, the books are helping me about 6 points on my grade. When I go to class at a high level of attendance, books are helping me about 10.5 points on my grade. So let's go back down here, finish filling this in. So as attendance and books go up together, we're getting an additive, what I would call an additive effect. So we're adding, it was 1.45. Okay. Or something like that. Okay. So as I read more, as I go to class more, books are adding more and more to my grade. So what do you mean here by low, average, and high of that moderator? And we're gonna add some context to these numbers here. Okay, so what do I mean by standardized books? What do I mean by low, average, and high? And so this is where we kind of go from the centered scores kind of back to the regular scores just for interpretation purposes. Now you can actually get the descriptives here from JASP, so I can click OK, click descriptives, and just get the means and standard deviations for books and attendance. So when I say a standardized book for every standardized book, what I mean is for every 2 books. So for every Z-score of 1 book, right? And that means that they're starting at 2 books and they're going up, here's the standard deviation, 1.4 books. So let's copy this over here. So standardized books means like every standard deviation, right? And that means it's 1.4 books. So for every 1.4 books, I'm getting 6 points on my grade, okay? Which is a difficult interpretation. That's why I said I would write it more like this for each standardized book. But really the interpretation is about the direction and creating this fan effect. What do I mean by low, average, and high of the moderator? So for a low person, that is 1 standard deviation below the mean. For an average person, that's the mean. Okay, so the mean attendance was 14.1. For low people, this is 1 SD below the mean. Okay. So I'm going to take 14.1 minus this time. The standard deviation here is 4.28. Okay. And that equals 9.82, or about 10 classes. And then for high people, I'm going to take 14.1 plus a standard deviation. And you're sitting there going, wait, we did this the other way a minute ago. I will explain that. Okay, and that is 18.38. Now earlier we subtracted a standard deviation for the high group because we were bringing them down to average. We had to bring them down a notch. That's the way I think about it. For the low group, we have to lift them up so they'll be average. But the interpretation of it is like, if I am going to class less than average, so if I'm going to class about 10 times, books are not helping me any. Okay, I might as well just quit. If I am going to class an average number of times, every standardized book is adding 6 points to my grade. If I'm going to class a lot, every standardized book is adding a whole lot to my grade. So the more I go to class, the more books matter, is the final interpretation for this analysis. Okay. So this here at this point highlights why people use different types of centering. Z-score centering makes creating the high and low scores very easy. You just add and subtract 1 for the standard deviation. It makes interpreting a little hard because it's every standardized book, right? And I have to figure out what standardized book means. That's for every standard deviations of books. It's kind of like interpreting beta. So mean centering is just a little bit more, not work, but you've got to create the scores by adding and subtracting that standard deviation, but it makes the interpretation a little easy because they're not standardized books anymore. It's just for every single book. So pros and cons of each side. For me, I'm just interested in like, what's that interaction mean? Well, here, what it means is that as attendance goes up, the impact of books on grades also goes up. And the best way to do that is to create a picture. So let's make that picture. I wanted my descriptive statistics, not here, but here. So let's create a graph. Well, unfortunately, there's no good way to do this, so I'm going to close all this out. And I found online this really great simple slope graph Excel document that apparently caused Excel to crash earlier. And what you do is on the first page under data, we're just going to enter the B values from our analysis and the constant. So I'm going to scroll up here. I'm going to go back to the very first original analysis. So I'm going to keep scrolling up here. And we're going to use this. So we're going to enter that intercept, which is 6160 here. Okay. Our X coefficient, this is the one that we didn't split, so we're going to use books, so 5.95. Our M coefficient, our moderator, so the one we want the separate lines for, we did 3 separate attendance ones, so we got 5.7. And our interaction coefficient here, which is 4.5. Now, nothing looks like it's happening here because all the magic is happening on this Graphs tab. And it's this first box. The second box is if you do a whole bunch of, if you were to do this as 5 separate standard deviation lines. We're not going to go that crazy. I've actually formatted this correctly too. But what it does is it calculates the scores for people who are low on our X predictor here. So what we would do is we'd fill this one in right here. We'd click on it. Come on, let me edit here. Our variable here that we're interested in is just books. Okay, so I'm either reading a low number of books or a high number of books. Our Y-dependent variable in this example is grade. Okay, final course grade, either way. Okay. And these are low, medium, and high for the slope. So I can actually change that over here. So x2 here, what is x2? Well, x2, oh, don't change it right there. Sorry. I'll come over here. Ooh, can I change it? If data is not equal to data. Ooh, not sure where to change that. I'll see if we change it here, we can cause this to not freak out. Yeah, so our low attendance, our average attendance, and our high attendance. We want to kind of play with where this, I am struggling today. There we go. Play with where this box is so that you can read it. But what you see in this picture is that fan effect. I'm going to copy that over here for our figure. Plop that in right. No, that's not the box I wanted. I'm going to copy this figure. Copy Excel. Play along. I'm going to paste this figure. There we go. And so we can see the analysis we just ran. So for a low number of books and low attendance, this blue line here, books and does not doing much. Reading one book versus reading all the books. For average attendance for a low number to a high number here, we're getting increases in final course grade. And then for high attendance, we're getting more increases in final course grade. So you should see that kind of fan effect that matches your B values. So if one of those B values have been negative, one of these slopes should be negative as well. And if we cut off the bottom here, because we didn't have anybody who made below a 40, this would get even bigger. And so you can kind of play with the graph a little bit to show how these slopes are different from each other, as long as you're not lying with graphs. So we could say, well, we didn't have anybody score below a 40, so we're not going to interpret that and kind of show the fan effect better. But this picture should match the interpretation of those B values, that we're getting this difference across attendance for the relationship between books and final grade. The way you report this analysis, you write it up like a regular regression in the first paragraph. So talk about the overall model and then the predictors. And then in the second paragraph, you'll talk about what the interaction simple slope effects are. And so all that together is moderation analyses and regression with JASP and Excel.